Hello everyone, so today we're going to be working with a three-phase rectifier, which is taking the three-phase from this delta on the left, and we are spitting out a DC current on the right side to this resistor. As you can see, we're using 6 diodes to be able to do this. We're trying to prove at 0.25 seconds, VAB is 120 volts, VCA and VBC are -60, which we can see here on the graph. So we're going to be doing this with our conditions. So the first thing we want to go over is ideal diodes. So I always remember the arrows pointing with the way the current's going to flow from positive to negative. We have the voltage drop across it. The current anode is going to be on positive, cathode on the negative, and it can act in 2 different ways. It can act as on or off. On is obviously going to be a short. Off is going to be open. The way I like to think about these diodes is that they act like a check valve in a fluid system. So it's going to prevent current from flowing against it, but it will allow current to flow with it. As we can see here, in the open condition, the current is going to be equal to 0, and the voltage will be less than 0. On the short, current's going to be greater than 0 while voltage will be equal to 0 because there's no voltage drop across it. It's just a shorted piece of wire. So for this, we have our conditions for each diode. Due to the firing order, we know that D1 and D5 are going to be shorted. We can see that here on a redrawn circuit. So D1 diode 1 and diode 5 are going to be shorted while the rest are going to be left open. And then these are the conditions that we're going to be trying to prove systematically as we go through this. So let's carry on. So I've taken this and we're going to redraw each diode in its own loop so we can do a KVL and Ohm's law. So first off, we have diode 1. So we have the VAB at 120 volts right here. We have diode 1 and we have the load resistor, which is 10 ohms. So we're going to do a KVL. So we have VAB minus voltage drop across diode 1 minus V0 is equal to 0. VD1 is equal to 0. Check, good. So that condition has been met. Next we're going to do a Ohm's law. So V equals IR. Now because they're in series, we know that the current flowing through diode 1 will be equal to the current flowing through the resistor. So current D1 will be equal to IR, which equals V over R, which equals 12, which is greater than 0. So check, we can move on. Diode 1 has been taken care of. Next we have diode 2. Redrew the circuit for you. So we have VBA. This is backwards from before. Then we have VD2. Little KVL, we have negative VBA minus VD2 equals 0. The voltage drop across diode 2 is negative 120. Check, that's good. And then we know because it's open, there's going to be no current allowed to flow through this, so it's going to be equal to 0. Next, moving on to diode 3. Again, we've redrawn it. We have VCA. Going to our sign convention with the KVL. We have VCA minus voltage drop across diode 3 is equal to 0. And obviously that will be equal to -60. And again, because it's open, we have no current flow, so it will be equal to 0. So diode 3 has been taken care of. So 1, 2, and 3, the conditions have been met. Next we just need to check 4, 5, and 6. So here we go for diode 4. We have VBA and we have VD4. So again, KVL. Voltage drop across diode 4 will be equal to -120 volts. Check. And then open, so we know there's going to be no current. Redrawn, it looks like this. So we have KVL of VAB minus V0 minus VD5 is equal to 0. Leaving that with voltage drop across diode 5 is equal to 0. We can do a little Ohm's law again. Same thing, comes out to 12 amps, which is greater than 0, so that's good. So we have proven that the conditions for diode 5 have been met. So now we just need to finish up with number 6. Do a little KVL again. We have negative VAC minus V0 minus VD6 is equal to 0, leaving us with the voltage drop across diode 6 is equal to negative 60, which is less than 0. Good. Then because it is open, we know that the current is equal to 0. So we have proven that all of the diodes in this scenario meet the conditions. One of the trickiest things that you'll run into when doing your own problems is trying to figure out of how to arrange these KVL loops when you're doing each and every diode. So the biggest problem you're going to have is when you're trying to do VD2, for instance, and you're coming around, you're going to go right back into diode 5, and they're going to be on the same line. So you always want to make sure that you're never picking two diodes across the load that are on the same line, as you can see right here. So 1 and 4, 2 and 5, 3 and 6.